So this lecture is about correlation and linear regression analysis. So just to recap, we said correlation is a value between 0 and positive 1, and also from 0 to negative 1, meaning that when correlation is -1, it means that we have perfect correlation. And when correlation is +1, we have also perfect correlation. When correlation is +1, or if correlation is a number from 0 to +1, then it means we have positive correlation. And when correlation is negative from 0 to -1, then we can say that we have negative correlation or inverse correlation. In other words, it shows that the relationship between two variables from 0 to -1, we can say the relationship is negative or inverse. And from 0 to +1, we can say the relationship between these two variables is positive. When you increase one variable, the other variable will increase. While on the other side, if you increase one variable, the other variable decreases, and the opposite is true. But we mentioned also the middle value, which is 0.5. And that's on the negative side, and also positive 0.5 on the other side. That's the middle value. And we mentioned that when correlation is from 0.5 to 1, then correlation becomes significant. And also on the other side, when the correlation is 0.5 to -1, correlation is significant. However, when correlation is below 0.5 and it approaches 0, then it loses its significance. So it is the same on the other side, that when correlation is less than 0.5 and all the way to 0, then correlation loses its significance. So if we are to look for correlation, let's say correlation between salary and any variable here, or if you are to look for its correlation between two values, let's say y and x, then it means that we are seeing that if there is any correlation or relationship, how that relationship looks like. Take an example. If y is the quantity demanded by the consumers, and x is price. Let's say like that. So what it means here is we are trying to see if there is any relationship between quantity demanded and the price. Always, quantity demanded by the consumers has inverse relationship with the price, because the higher the price, the lower the quantity can be demanded, because it reduces the purchasing power of the consumer. So when prices are increased, consumers tend to reduce their purchasing. But if we are looking at the quantity, let's do this. So let's say if we have to look at the quantity supplied. So if the price goes up, the quantity supplied in the market also will increase, because suppliers will be motivated by the price. And we can see if the price goes down, suppliers will also reduce the supply of goods, because they are disappointed with the lower price. There's no any point when suppliers will be motivated by the lower price. The higher the price, the more the quantity supplied, And but on the other side, the lower the price, the higher the price, the lower the quantity demanded. So that's the relationship which we can mention, we can test by using correlation. And so by definition, we can say correlation is the relationship between two variables where correlation can be zero, meaning that there is no relationship. And also correlation can happen if there is a negative correlation then between two variables. Then we can see that we're going to have minus values up to minus 1. And also, if there is a positive correlation, then we can see that correlation to be positive up to positive 1. So correlation is the value between minus 1 and positive 1. You should this should be different from the definition which we had for probability, where we say that probability is a value between 0 and 1 that measures the occurrence of an event. We don't have negative probability, and we don't have any value above 1. So anyways, here we have this data, and let's try to find correlation between salary and years of previous experience. So we can use Excel function to find the correlation between those two variables. And the Excel function that we can use is this one. So all you have to do is to put equal sign, and then you type Corel. And in this case, you can see that we need array 1 and array 2. So we will click on salary as our first array, and then years of previous experience is our second array. And if you close the bracket and enter, then we can see that the correlation between salary and years of previous experience. So let me write here, years of previous experience. So the correlation between salary and years of previous experience in our case is 0.029 or 0.03. So in this case, you can see that there is correlation. There's some relationship between salary and years of previous experience, but we can say that this is not significant. The correlation is not significant because it is positive, but you can say it's way below 0.5 and almost 0. So that one we can say the correlation is not significant. However, for us to say it is significant or it is not significant, we could test this correlation. And in order for us to test this correlation, we should first start by providing hypothesis. So here we can say HO, meaning that correlation is not significant. It is almost 0. And in this case, we can provide probability. If it's not given, then we go with the default 95 confidence level. And then we have alternative hypothesis, where we're going to say that correlation is significant, or it is significantly different from 0. So you can say not equal to 0, or you can put slash on the equal sign to show it is not equal to 0. And in this case, we want to prove this if we can provide some evidence. And one evidence we can provide is the probability value. We need to come up with the probability value that will prove correlation not to be 0 or is significantly different from 0 when p-value is less or equal two significance level. If we are using 95%, then we can say significance level, or let's say 5%. We could say 5% because we know that out of 95%, we have 5% divided by 2. So, hold on. So in this case, we are saying correlation is not equal to 0, meaning that it can be negative or it can be positive. So it can be on the left side of the normal distribution curve, or it can be on the left side of the normal distribution curve, left or right. So in this case, we can actually see that this 5% will be divided by 2. However, because we're going to deal with the sample size, it's going to determine if our correlation is two-tail or one-tail. But this is how we can create our hypothesis and be able to test this hypothesis to see if this 0.02935 is significantly different from 0, and that will be proved by the probability value. And we can say that that correlation is significantly not 0 if that probability will be less or equal to the significance level. So let me write here, significance level. So in order for us to get this probability, we need to find the t-value of the correlation between these two variables, and so call it t correlation value. And when we find that t correlation value, then we can find our probability. So we need to know the formula of obtaining t correlation value, which will be calculated. So the formula is r divided by the square root of 1 minus r squared, and this value divided by n minus 2. So let me close the bracket here, put 2 brackets, and here we put another bracket. So it is r divided by the square root of 1 minus r squared divided by n minus 2. So here n minus 2 means degrees of freedom. We have degrees of freedom of the salary and also degrees of freedom of years of previous experience. And if we are dealing with only one variable, we could say n minus 1. That's how we can get our degrees of freedom. And so in this case, we have n minus 1 for the salary and n minus 1 for the years of previous experience. And so we put them together to find the degrees of freedom 1, which is n minus 2. So in this case, we know that our r is what we have found. Let me put equal sign and click here. That is our r. And n, which is the sample size. If you look at our data, you will see that we have 40, they should be 46. So n is 46. And then we need r squared. So we will put equal sign here, click on this value, and then put r squared. So in this case, we have our r squared. Now, we have also the n minus 2. Let me just put here n minus 2. And so put equal sign, click on 46 minus 2, then we have 44. So we have r1 minus r squared. So 1 minus r squared. So in this case, we put equal sign, click, type 1 minus r squared here. And if you enter, you have that value. So we will take 1 minus r squared divided by n minus 2. So in this case, we know 1 minus r squared divided by n minus 2, it is this one. So I'm going to put equal sign, click on this, and divide by n minus 2. And that's the answer. We have 0.02271. So we need to find the square root of this. So all I need here is we only need the square root of this value there. So I'm going to put equal sign and type SQRT, and that is the square root of this. And then you, if you enter, we have the square root. So we have already solved the below data. Now we're going to take r divided by this value. So we need to find r divided by the square root, which we have obtained here. And so I'm going to put equal sign, click r, divide by this value here. And so you can see that the t correlation, so t correlation value is actually this value here. Now, if that is t correlation, we need to find probability value. So let me type here p value. The probability value in this case, if you can remember, we can put equal sign and type t. This you could use, let me go back. If you type t, you can see we have t dot dist and so forth. All I want you to do, don't go with the dots for now, but just type TDIST to get the probability value. And in this case, it will ask you to put the X value, which is the T correlation. And now you're going to provide the degrees of freedom. And in this case, we're going to take only n minus 1. So it is 46. And you're going to determine how many tails. And from this hypothesis here, you can see that we have 2 tails. It can be negative or it can be positive. So I'm going to click on the t value, and degrees of freedom will be 46 minus 1, which will be 45. And the number of tails, we're going to take 2 tails and close the bracket. If you enter, you can see that our p-value is 0.84643. But here you can see that our p-value, or any probability value we're going to obtain for it to be significantly different from 0, that probability value should be less or equal to 5%, which is 0.05. But here we have 0.8, which is greater than the p-value. So in this case, we will fail to reject HO. And if we fail to reject HO, then we can say that this correlation is not significant. And we have proved it by using the probability value. And in this case, we can say that salary do not depend on the years of experience. So for you to get a job in this company, you don't really need to have experience, because your experience will not determine your salary. We can also find the correlation between salary and another variable. So let's see if there is any correlation between salary and the years employed. So let me write here salary and years employed. And let's see if there is any any correlation. So I'll put equal sign and type Corel, and all I'm going to do is the first array will be our salary, comma sign, and then we're going to select years employed, and we'll close the bracket and see what correlation do we have. We have a correlation which is pretty good, which is 0.8 or 0.6517, and therefore we can say the correlation is 0.77 if we are to consider 2 decimal points. But anyways, when you look at this correlation, we can see that it is positive, and therefore there is a positive relationship between salary and years employed. And also this correlation is way beyond 0.5, and it's approaching 1, and so we can say that this correlation could be significant. But if we need to test, all we have to do is to change this correlation here by replacing the other one, and so everything will change and prove if the correlation is significant or not. So let me change this value here and put 0.76517 and see if the probability value will be less or equal to the significance level. If you enter, you will see that this probability value is pretty small. You can see we have exponential value, meaning that we're going to have 0.10 zeros and 1. So in other words, the probability is actually 0. So it is, in this case, this probability for the salary and the, what we call it, and the years employed, the probability value is way less than significance level. And so in this case, we can say there is this correlation is significant, or it is significantly different from 0. And we can say that salary depends on years of employed or tenure, meaning that the longer you stay at work, then your salary will improve. Probably there is a significant yearly increase of the salary. So let's use another variable. Let's look at the correlation between salary and years of education. So in this case, let me just put it here: salary and years of education. So let's see what answer do we get here. So in this case, let's put equal sign correlation, select Corel, and the first array as usual will be our salary, and the second one will be years of education. If you close the bracket, you can see we have also a strong correlation between salary and years of education, because if this was significant, this definitely will be significant. Even if we change the value here, let's see, 0.77699, and if you enter, you can see the probability value is very small, to show that it is less than 5%, and therefore we can say that this correlation is significant. Let's try one more, salary and another variable, and in this case, let's consider gender. So let me put here, and so in this case, we are trying to find if there is a correlation between salary and gender. Remember, always we have to use this hypothesis here. Let me highlight our hypothesis. So we are just referring to this hypothesis to test any kind of correlation. And so in this case, let's see if there is a correlation between salary And so in this case, we're going to select salary and then gender. And if we close the bracket and enter, you can see we have minus 0.24868. If we are to consider 2 decimal points, we can say the correlation between salary and gender is minus 0.25. And therefore, do you think this is a significant correlation? We need to create this hypothesis, and we need to test it as we did here. So let's change this correlation to look like this and try to find out if that correlation is significant or not. So I'm going to click there, put equal sign, and I'm going to select this correlation, which is gender, and see what happened. Now, you can see that correlation shows the hashtag now, meaning that there are some problems. The problems actually happen when the t value, where is the t value here? This t correlation value is actually minus 1.7, because this correlation shouldn't be minus. It should always be positive. And in this case, I'll click here and I'm going to type absolute ABS. We'll make that value to be absolute always. T value should not be negative. When it is negative, then that means you won't be able to find probability value. And so in this case, we will change it into absolute value, meaning that whether we get positive or negative, it's going to be negative positive. So if you enter, now we have absolute t correlation value, and therefore it will give us the probability, which is 0.09. And in this case, you can see that this correlation is not significant. It is not significant because the probability value of this correlation is greater than 0.05. And therefore, this correlation is not significantly different from 0. And in this case, we can say that gender is not as such significant. We can say that gender does not determine somebody's salary. And you can see this correlation, as we mentioned before, it is way below minus 0.5, and so it's approaching 0, and therefore it loses its significance. And that's what we have found for salary and for also years of previous experience. Now we'll try one more. Let's look at salary, and let's see department. We'll stop there. So let's say, so we will try to find correlation between salary and the department. So here we'll do exactly the same, type correl function, and all you have to do is you click on the salary, and the second array will be department, and if you enter, you will see that correlation is 0.33748. So this correlation, we can say it is positive, but it is less than 0.5, and so we would say it may not be significant correlation because it's way below 0.5. As we said before, if correlation is between 0.5 to 1, then that correlation is it's a significant. But when it starts from less than 0.5 and below, then we can say that it's not significant. And so with that conclusion, we could say that this correlation may not be significant. However, we need to test it. And if we test this, actually it's going to show that it is significant. So let's change this value here, put equal sign, and replace that value with this one. If you enter, you will see that the probability value is 0.02, meaning that it is less than 5%. And therefore, this correlation actually is significant in this case. So it is important to test our correlation, especially if it is close to 0.5. Probably sometimes it can be significant. And so you could see that this initially we may think it wasn't significant, but when we test it, the p-value is less than 0.05. So that's one thing. And you can see that we've been looking for the correlation by looking at correlation between a value and another value. However, in this case, we have a number of values. You can see that we have salary with all these variables. So do we need to find a correlation of one variable and another, as we have done? We don't really need to do so, because we can use data analysis to find a correlation, or to find the matrix of the correlation between salary and all these other variables. So I'm going to do it here. And in order to find data analysis, because I'm using Mac, I need to add ins. So I'll go to the tools and Excel add-ins. You know how to do it in Windows. And all I'm looking for is the analysis toolpath. I'll click OK. And so in this case, we'll go to my data. When you click on the data, you will see data analysis here. If I click on the data analysis, then we have all this kind of data analysis. All we're looking for is the correlation. And so here's correlation. Let me click OK. And in this case, our input range will be from salary to the number supervised. We are putting all of them together. They should be arranged in columns. I think that is better. And the first row should be labels. And so I'm going to select the output range. So I'll click in here, and I need it to show up here. So I will click OK. And in this case, you will see that we have this matrix. And if we pick up the first row, the first two columns, sorry, you'll see that it will give us correlation between salary and salary itself, correlation between salary and years of previous experience, salary and years employed, salary and years of education, with gender, department, and the number supervised. And you can see that we just obtained the same values as we have here, 0.34, negative 0.25, that's what we have here, 0.78, this one here, 0.76, that's the one, 0.77, that's what we got here, and also the first one, which was 0.02935. And so that analysis will help us to get correlation between salary and other variables. But also, this is a matrix. So we can look at the correlation between years of previous experience by itself, correlation between years of previous experience with years employed, correlation between years of previous experience with gender and so forth. The correlation between previous of years of experience and years of education is not significant. It is less than 0.05, but we need to test it. And we can also test all these other correlations to see if that there is a relationship between years of previous experience and other variables. You could see also that we have correlation between years employed with years of education, gender, department, the number supervised. Years of education as well, we can look at the correlation of that with gender, department, and number supervised. We can also look at the correlation between gender and the department and number supervised. And finally, we can look at the department and number supervised. So that means we are able to test correlation not only between salary and the other variables, but we could also look at correlation between these other variables, one variable and another. So that's how we can use data analysis to find correlation.